We are going to look at section 4.2, and this is activity 2, question number 3. Consider the following sequence of shapes constructed from matchsticks: figure 1, figure 2, figure 3. And we're doing a similar thing here where we're talking about how we see the shapes growing and the total number of matchsticks in each figure, and then trying to extrapolate out and figure out how many matchsticks would be in figure 10 or figure 100 without actually having to draw the figure. And then generalizing that to find a formula for the matchsticks, number of matchsticks in figure n. So I think in this video, what I'd like you to do is obviously pause it and see what you see. Think about how you see the shapes growing. And then what I'll do is just go through a couple different ways that students might see these shapes growing, and then not actually complete the whole activity with the formula and everything. Just let you think about which one of those makes sense to you, or which one maybe is in line with what you were thinking, and then try to complete the activity on your own. So take a minute or 2 or 10 and pause the video, work through this as much as you can, and then start the video when you're ready. All right. Well, what we first could do is actually just count the number of matchsticks. And sometimes when you actually start counting them, you get an idea about how you see the shapes growing. So maybe someone might count them by saying, well, I see 4 here, and then I have 2 plus 2. Maybe someone actually counts them that way. I see 4 and then 2 plus 2 for the tops. So that would give me 8. And then they go to the next figure and they're like counting these. Or maybe they're doing that. So then they count 1, 2, 3, 4, 5, 6, 7. And then I see, and then they do these top ones, right? There's 1, 2, and 2. I have 4 of those, so that would give me 8. Maybe they actually write 2 plus 2 plus 2 plus 2, or maybe they write 8. And then they go to the next one, and they say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of those. Let's see if I can make this fit. This would be for figure 3. There's 10 of those. And then they count these 1, 2, and then I've got, how many of those 2s do I have? 6? Maybe they do that. Maybe they go 6 times 2 now, right? Or maybe they up here they did 4 times 2. So we start to see patterns in the way that we're counting, right? There's a pattern with these numbers right here. 4, 7, 10. And then there's a pattern with these numbers. 4, 8, 12. Or 2 times 2, 4 times 2, 6 times 2. So sometimes we see patterns in the way that we count. Let's look at another way that we could count those, and another way we might see patterns. Let's see. Maybe a student actually is just counting these vertical toothpicks, and then they just count the number of triangles, right? So I've got 2 triangles there, and each of those triangles has 3. So then maybe they say, well, I've got 2 triangles, and each of those triangles has 3 matchsticks. And then they do the same thing with the next figure. Now I've got 3 of these vertical matchsticks, and then I'm going to count the number of triangles. I have 1, 2, 3, 4 triangles, and each of those triangles has 3 matchsticks. Let's do it for the next shape. Okay, so count the vertical ones. 1, 2, 3, 4, plus, how many triangles do we have now? 1, 2, 3, 4, 5, 6 triangles, and each of those 6 triangles has 3 matchsticks. So then we can look for patterns here. So we could see the vertical matchsticks, we could see that pattern. That's increasing by 1. And we can also see how it relates to the figure number, right? If I take the figure number and add 1, take the figure number, add 1, take the figure number, add 1, I get the number of vertical matchsticks. So that's going to help me think about a formula or possibly figuring out how many matchsticks are in the 10th figure. All right, what about the triangle part of this counting? Well, the 3 stays the same, right? So that's always going to be a 3. In my formula then, that's going to be a 3. If I'm figuring out the number of matchsticks in the 10th figure, that's going to be a 3. Now I'd have to figure out this number right here. How do I get this number? We can see it's increasing by 2 each time. But to write a formula or to figure out how many matchsticks will be in figure 10, what we really need to do is find a relationship between the figure number and this blue number. Maybe we'll complete this one together with figure 10, just so you can see this way of thinking. I had to put that 3 in there because we couldn't see it. Okay, so for figure 10, without drawing it, let's see, I'm going to figure out the yellow number, which is the vertical things, vertical matchsticks, plus this light blue number, and then we're going to times that by the pink number, which is the number of triangles, which is always 3. Or not the number of triangles, the matchsticks in a triangle. Okay, so the yellow numbers are the vertical matchsticks. So in figure 1, there were 2 of them. In figure 2, there were 3 of them. In figure 3, there were 4 of them. How about figure 10? How many vertical matchsticks would be in figure 10? Well, there's 1 more than the figure number, right? So that would be 11. Okay, now, this blue number was the number of triangles. So in figure 1, let me see if I could squeeze this in here a little bit better. In figure 1, there were 2 triangles. In figure 2, there were 4 triangles. In figure 3, there's 6 triangles. How many triangles would there be in figure 10? You got it? There's twice as many, right? Twice as many triangles as the figure number. So in figure 10, there would be 20 triangles. And each of those triangles would have 3 matchsticks. So now I can figure out the total number of matchsticks in figure 10, which would be 11 plus 60, or 71. So sometimes how you count them can help you figure out a formula, okay, to figure out how many matchsticks are in subsequent figures. So let's say now I wanted to figure out how many matchsticks were in figure N. So let's get rid of these numbers here. Okay, so figure N, we're still going to think the same way. How many vertical matchsticks would be in figure N? And what are the number of triangles in figure N? And each of those would have 3 matchsticks per triangle. All right, so again, we're looking at the pattern. Let's look down here again. The number of vertical matchsticks in figure 1 is 2, in figure 2 is 3, in figure 3 is 4 vertical matchsticks. So how many vertical matchsticks would be in figure N? It's 1 more, right? Figure 1 is 2, 2 more than 2 is 3, 1 more than 2 is 3, 1 more than 3 is 4. So if the figure number here is N, there would be N plus 1 more vertical matchstick. Okay, now how about the number of triangles? Remember how we got the number of triangles? In figure 1, there are 2 triangles. In figure 2, there are 4 triangles. So we're doubling, whatever the figure number is, we're doubling that to get the number of triangles. In figure 3, there are 6 triangles. Doubling the figure number. So in figure N, there would be 2 times n triangles. So there's our formula. Now we could make it a little bit nicer, but this is the formula right here to figure out the number of triangles in figure n. We could use this formula to figure out the number of triangles in any figure number, even figure number 65. We would do 65 plus 1 plus 2 times 65 times 3, and we'd have our answer. Now to make this look a little bit nicer, we could multiply the 3 times the 2 and get 6n. And then we could add 1n plus 6n to get 7n. And we could write that as 7n plus 1. But if you didn't do that, that's fine. Any of these iterations of this are perfect. The reason I'm simplifying it out like this is to show that if you did it a different way, if you counted it a different way, your formula should simplify to be the same as this formula here. And another way you can check your formula is to actually make sure it works for these values. So let's do this out using the order of operations, the number of matchsticks. You probably already have this done. All right, so we have 3 times 2 is 6, plus we have to do the multiplication first, so that's 8. 4 times 3 is 12, plus 3 is 15. 6 times 3 is 18. Those are our triangle matchsticks, plus the 4 vertical ones is 22. So now, if we look at this formula, 7n plus 1, let's write this down here, 7n plus 1. So what this says, if I take the figure number, and you should have how you see the shapes grow in here. I'm just using this board space to write this down. This formula says take 7 times the shape number and add 1, and it should work. So if I take 7 times figure number 1, I get 7 times 1 is 7 plus 1 is 8. All right, 7 times the figure number plus 1. So 7 times 2 is 14 plus 1 is 15. 7 times the figure number plus 1, so 7 times 3 is 21 plus 1 is 22. So that's another way you can check your formula, is actually see if it works and gives you the number of matchsticks that you were able to just physically count. All right, if you counted this up a different way and got your formula a different way, I think that's great. I'll look forward to seeing it. I just wanted to illustrate one way to do it, and as I mentioned earlier, this makes this particularly challenging because we can't share out with all the different ways we're doing this. But again, I think this would be a good thing to do in our groups, is to talk about how we did this. Now, I didn't make a video for number 2. I had you guys do that one on your own, so this might be a good one to share out in our groups, how we were thinking about this one. I know these are a little challenging to get used to, but just keep working at it, keep thinking about it, keep messing around with it. It's kind of fun. Think of it as a game, a little puzzle to solve.